Hey, welcome to this video, which is the first in a series I'm going to create on object-oriented programming and how to code specifically in Java. Okay, so let's just get a move on, shall we? Okay, so I've got a little activity for you to start off with for today's video. Okay, what I want you to do is just have a look at these three images on the slide. All right, and what I want you to tell me is what have they got in common. Okay, so I'm going to give you a minute to try and think about that. So I want you to pause the video and then give yourself a minute to think about it, and then once you've had to think about it, unpause the video and we'll move on. Okay, go. All right, so hopefully you've had to think about it. All right, and maybe one of the things that you came up with, maybe you recognize the fact that that picture is by Picasso. And is an example of abstract art. Okay, we've also got the London tube map. It doesn't make any difference that this is the London tube map. It's just a tube map. Okay, and we've also obviously got Windows, the operating system. Now, the one thing that these have all got in common, all right, is they're all types of abstraction. So what I'm going to introduce you to now is what I mean by abstraction. Okay, so in terms of computer science, and I would always recommend that you go and back this up on your own. Okay, so make sure you agree with my definition. Okay, but in terms of computer science, when we talk about abstraction, what we're talking about is removal of unnecessary detail. All right, so we're taking away information that we feel the user does not need. All right, and if we think back to that, so if we look, that's what Picasso was doing. Okay, Picasso in his abstract art was taking away things that he felt were unnecessary, that didn't truly represent the people that he was trying to represent through his art. Okay, we've got the London tube map. If you think about what kind of data does that take away, or what kind of information does that remove? Well, if you think about that tube map, it just shows you which lines are which using the different colors. Okay, it shows you which lines joins together the different stations, but it doesn't tell you anything about the distance between the stations or the amount of time it takes to get between stations or anything like that. Okay, it's an abstraction because they've removed that information because they didn't feel it was necessary. Okay, now we're going to talk about a little bit more about why Windows is there and why that's an example of an abstraction. I'm just going to move back to this slide. Okay, so obviously Windows is a lot more specific to computer science, which is what we're talking about. Okay, so Windows is an example of an operating system. All right, and obviously an operating system is a great example of extraction. Why is it an example of extraction? Because it hides lots and lots of things from you. All right, it hides lots of complexity. So a great example is when you save a file. All right, so when you save a Word file, for example, or an Excel file, you just click the save button, but actually there's a lot that goes on behind the background. In the background, sorry, but do you need to know what goes on in the background? No, you don't. Okay, so that's an example of abstraction. Okay, now what I want you to do is, again, I want you to take a minute and I just want you to have a think about that description of abstraction and those examples I've given you, and see if you can come up with your own abstractions from the real world or on the computer. Okay, so take a minute and I'll be back. Okay, so hopefully you came up with your own examples. Another nice one I like from the real world is driving a car. Okay, and that's a great example of abstraction because you can drive a car. You don't need to know anything about the internal combustion engine. You just get the gas pedal. As long as you know where the gas pedal is and know how to put it into drive, all right, you can drive that car. You don't need to know anything about how it works. All right, and that's so that steering wheel and that gas pedal are great examples of abstraction because they're hiding the complexity of the internal combustion engine from you. Okay, hopefully that makes sense. Okay, so programming languages are of course also an abstraction. Okay, hopefully you've learned in another lesson, and if you're not sure, just put some comments in the put a comment in the comment section and I'll make another video. Okay, but if you want to write, if we were going to be true to writing computer programs, we'd have to write them in machine code, in binary, all right, so that the computer could understand them, all right. But that's a very, very complex thing to do, and it takes a long time. Okay, and so we don't do it. So the programming languages that we use are a form of abstraction because they are hiding that complexity from us. We don't need to know anything about the process of converting it into machine code so that it can run on a computer. We just need to know the dictionary and the syntax associated with that language. Okay, so programming languages are also an abstraction. Now, Early imperative languages, and again, I would recommend you go away and look up that term imperative. All right, so make sure you do that. Early imperative languages that we used did have a problem. Okay, and I've got a little bit diagram here to represent the problem that we had. Okay, so this is the problem. Okay, we've got a real world problem. Okay, and we create a model of that real world problem. Okay, and then what we've got is a programming language on a computer. All right, and the problem is, how do you map the two? Okay, so how do you create using a programming language that's appropriate for a computer, okay, a solution to a problem that exists in the real world? Okay, and actually that's a really quite difficult thing to do. All right, and so there's a programmers for years have had difficulty trying to map the two. Yeah, mapping that the solution, the computer solution, to the real world solution. Okay, so and what happens is, as I said at the bottom of the slide there, is we end up producing programs that are very difficult to write and are very expensive to maintain. Okay, and if you do any research on software engineering projects, okay, you will see that a lot of software engineering projects go wrong. Okay, and there's lots and lots of problems associated with software engineering projects, and that's part of the reason, because it's very difficult to take a real world problem and try and apply it in a computer system. Okay, so object-oriented, sorry, I went too far there, I apologize. Object-oriented programming, what it attempts to do is it attempts to solve this problem. Okay, so what it tries to do is it provides you with tools that allow you to represent elements of the problem space in the solution. Okay, so rather than having to work out, and again, you spend a lot of time doing this in imperative languages, rather than trying to work out how to solve the problem on a computer, okay, actually what you're trying to do is you're trying to take elements of the problem in the real world and you're trying to recreate them on the computer. Okay, and object-oriented programming provides us with tools that allow us to do that. Okay, now what do I mean by that? Well, I'm going to give you a little bit more detail of what I mean by that. Okay, so let's move on. Okay, so these elements that we take from the real world, okay, they are represented in an object-oriented language as objects. Okay, and maybe hopefully you got that from the name. Okay, and so we have our object-oriented programs, okay, are made up of objects, and we as programmers are going to be able to determine what those objects know and what they can do. Okay, and we can also make them interact. Okay, and it's that interaction of objects that allows us to solve problems using an object-oriented programming language. Okay, now where do object-oriented programs come from? Okay, well, all object-oriented programs have these 5 characteristics. Okay, so this is what we are looking for in our object-oriented programs. Okay, so everything in an object-oriented program is an object. All right, so that's really important in object-oriented programming. Okay, I've already kind of spoken about this, that a program is basically going to be a load of objects telling each other what to do by sending messages and interacting with each other. Okay, each object has its own memory, which is going to be made up of other objects. Now, that might sound a little bit confusing at the moment, but that'll become a bit more apparent as we work our way through the lessons. Okay. Each object has a type, and we're going to talk a little bit more about what we mean by that in a minute. Okay, and this is a really important concept, but again, it might not make much sense at the moment about why it's important. Okay, is that all objects of a particular type can receive the same messages. Okay, and that's a really important concept in object-oriented programming. Okay, so these are the characteristics that we find in a pure object-oriented program. Okay, now, what does this mean? Okay, we talked about this idea of type, and we said that every object has a type. Okay, now I'm going to give you an example from nature of what I mean by type. Okay, so if you think about it, we can say that a lion or a tiger is a type of cat. All right, and that's what we mean by type. Okay, so all objects, although they're unique, okay, they are also part of a class of objects that have characteristics and behaviors in common. Okay, so if you think about that, you know, a lion and a tiger are different objects, they're different cats, and you have individual cats and individual lions, okay, but they all have similar characteristics and behaviors, all right? They all do similar things, they all act in a certain way, and that's why they've been categorized as a type of cat, okay? And so that's really, really important in object-oriented programming, this idea of type, okay? So, just to reiterate that point, okay, basically we've got two lines here, and again, this is the difference between a type and an object, okay? So we say an object is a type of something, okay, and what we've got here are two objects, but they're both of the same type, okay, but each object is individual, so we've got two individual lines, okay, but they're both of the same type, which means they share characteristics and behaviors, okay, but they are both individual lines. There are two separate lines there. Does that make sense? Okay, maybe just pause the video if you're not too sure, just have a think about what I've expressed there and see if it makes a bit more sense after you've had a think about it. Okay, so if we move on to create the sense of this idea of type in Java, okay, what we do is we use the class keyword, when we use the class keyword, basically what we're doing is we're expressing a type, okay. So basically what we do with a class is we use it to describe a set of objects that have identical characteristics and behaviors, okay. So any object of that type will have identical characteristics and behaviors, okay. And so that class object allows us to define an object almost, okay. And some people describe it as a template. It's a bit like a template that we can use to create objects from. Okay, now I'm going to give you an example using a programming language called BlueJ in a minute of what I mean by that, and hopefully it'll make a bit more sense. Okay, now we can use a class diagram to represent a class. Now you don't need to worry too much about the format of these diagrams at the moment. We'll talk about it. There will be lots of opportunities for you to have a go at creating class diagrams and to understand a little bit more about classes, okay? But what I want to show you is this is a class that I've created just as an example, okay? And it hopefully it'll help me explain to you the difference between characteristics and behaviors, okay? So we've got a human class here that I've created, and so what we've got at the top here in our diagram is the name of the class, okay, and then underneath the name of the class we've got the characteristics, okay? So the other way to think about these are all things that our object knows, okay? So for example, we've got here a human knows its name, it knows its gender, it knows its date of birth, and it knows its address, okay? Now in the class we define those characteristics. So we say a human knows its name, we knows its gender, we know its date of birth, and we know its address. When we create the object of a type human, okay, that's when we set those characteristics. So you know, all humans have a name, but their name is not the same. They have different names, okay? All humans have a gender, okay, but their gender is not the same. They have different genders, okay? So you know, in the class we are defining those characteristics, and we're saying, well, these are the characteristics of a human. These are what it knows, okay? And when we create the object, that's when we set those characteristics, and those are individual to each object, okay? So underneath that then, and this is the second important part of our class, is the behaviors, okay? So this is what an object of this type can do, okay? And all objects of this type will be able to do these behaviors, okay? So all humans can talk, all of them can walk, all of them know how to run away, okay, that's a built-in instinct, okay, all of them know how to eat, and all of them know how to drink. Now, they may do that slightly differently, okay, so some humans may do things differently, and that's an interesting topic for another lesson, okay, but all humans have those behaviors, okay, so they can all talk, walk, run away, eat, and drink, all right, does that make sense? And those behaviors and those characteristics are defined in the class, okay? So that's it for my slideshow. So what I'm going to do is I'm going to move on, and I want to show you some code. I want to give you an example of what I mean by characteristics and behaviors in some code, okay? So what I'm going to do, this is a program called BlueJ, okay, and it allows you to create classes and objects, okay, using Java, all right. And what you can see here is I've got 4 classes here, okay. So I've got a class called canvas, I've got a class called circle, I've got a class called square, and I've got a class called triangle. Okay, and next to that slide, where you can see my my 4 classes, you can also see the code that makes up the circle class. Okay, so this is the code that's made up the circle class. Now this is just an example from BlueJ, so when you finish watching this video, you can go away and install BlueJ and get some of the example code, and you can have a look at this. Okay, so the meaning of these arrows is kind of outside the scope of today's lesson, but we will be talking about those in the future. Okay, but what I want to show you is what I can do here. So when I right click on the class, okay, I can now make an object of this type. Okay, so I can go to new circle. Okay, and now what I'm doing is I'm making an object of this type, and I can give this object a name. Let's call it John. Okay, it doesn't matter what you call it. All right, so I've now got an object of type circle. Okay, now if I want, I can make another object of that type. Okay, so I can go new circle again. I can make another circle. Okay, so I can go James this time. All right, and if I want, I can make an object of type square. So I can then go new square, and I can make another object. Let's say Andy this time. Okay, oh, that was close. All right, so I've now got what I've now got are 3 objects that I've created. Okay, and I've created them using these templates, basically the class. Okay, now what we can see over here is the code for the circle class. Okay, so what you can see here, these are the characteristics. Okay, so each circle has knows its diameter. It has an X position, a Y position. Okay, it has a color, and it has is visible. Now look, if I right click on my object, then all right, I can't see those characteristics, and the reason why I can't see those characteristics is because they're all private. Okay, now again, the reason why we've made them private is outside the scope of this lesson, but we will be talking about that in this sequence of lessons. Okay, now what we see down here then are all of the behaviors. So these are all the things, okay, that my circle can do. All right, so these are, as you can see, that it can I can make it visible, I can make it invisible, I can make it move right, I can make it move left, I can make it move up and down, and I can make it move horizontally and vertically. Okay, so these are all the different methods that I can do. So let's try this. Let's try one of them. All right, and let's say let's make it visible. Okay, now you can't see what happens. Okay, but what I'm trying to highlight to you, okay, is because I have an object. I'm sorry, they've just disappeared. Okay, because I have an object of that type. All right, that object has all of those behaviors. Okay, and if I make another object of the same type, okay, again, like I've done here, again, that also has all of those behaviors, so it can do all of the same things. All right, so this has been lesson 1, an introduction to Java. Your first task, what I'd like you to do, hang on, I'm just going to let's go back. Your first task, so let me just go back. Let's start there and that again. So this has been our first lesson, an introduction to Java. Hopefully this has made sense. But as I said, if you would like any more information, just put your question in the comment section of the video. Okay, what I'd like you to do, your task now, is to download BlueJ. Okay, find BlueJ, download those example programs, okay, and have a go at making your own objects and messing around with the behaviors. All right, thank you for watching.